NCERT 6th class chapter 10 Fun with Magnet. Paheli and Bujo went to a place where a lot of waste material was piled into huge heap. Something exciting was happening. A crane was moving towards the heap of junk. The long hand of the crane lowered a block over a heap. It then began to move. Guess what? May pieces of iron junk were sticking to the block as it moved away. They had just read a very interesting book on magnet and knew immediately that there must be magnet attached to the end of the crane that was picking up iron from the junkyard. You might have seen magnet and have been enjoyed playing with them. Have you seen stickers that remain attached to iron surface like almaris or the doors or refrigerators? In some pin holders, the pin seems to be stitching to the holder. In some pencil boxes, the lid lifts tightly when we close it, even without locking arrangement. Such stickers, pin holders, and pencil box have magnet fitted inside. If you have any one of these items, try to locate the magnet hidden in these. How magnets were discovered. It is said that there was a shepherd named Mangus who lived in ancient Greece. He used to take his herd of sheep and go to the nearby mountain of grazing. He would take a stick with him to control his herd. The stick had small pieces of iron attached at one end. One day he was surprised to find that he had to pull hard free his stick from a rock on the mountainside. It seemed as if the stick was being attracted by the rock. The rock was a natural magnet and it attracted the iron tip of the shepherd stick. It is said that this is how natural magnets were discovered. Such rocks were given the name magnet, perhaps after the name of that shepherd. Magnet contained iron. Some people believe that magnets was first discovered at a place called magnesium. The substance having the property of attracting iron are now known as magnet. This is how the story goes. In any cases, people now have discovered that certain rocks have the property of attracting piles of iron. They also found that small pieces of these rocks have some special properties. They named these natural occurring material magnet. Later on, the process of making magnet for price of iron was discovered. These are known as artificial magnet. Nowadays, artificials magnets are prepared in different shapes. For example, bar magnet, horseshoe magnet, cylinder or ball-ended magnet. Show a few such magnets. Take a plastic or paper cup, fix it on a stand with the help of clamp as shown. Figure 10.5. Place a magnet inside a cup and cover it with a paper so that the magnet is not visible. Attach a thread at a clip made of iron. Fix the other end of thread at these bases of the stand. Mind you, trick the involved here is to keep the length of the thread sufficient. Break the clip near the base of the cup. The clip is raised in the air without support like a kite. Effect of magnet: a paper clip hanging off air. Magnet and non-magnetic materials. Let us walk in the footsteps of the magnets only. This time we will change the positions of magnet and the iron. There will be magnet at the end of our shepherd stick. We can attach a small magnet to the hockey sticks, walking stick, a cricket wicket with a tap of some glue. Let us now go out on the magnesia walk through the school playground. What does our magnesia stick pick up from the school ground? What would object in the classroom? Collect various objects of day-to-day use from your surrounding. These test these with the magnesia sticks. You can also take a magnet, touch these object with and observe which object stick to the magnet. Prepare a table in your notebook shown in table 10.1 and record your observation. Look at the last column of table 10.1 and note the object that are attracted by magnet. Now make a list of material from which these objects are made. Is there any material common in all objects that were attracted by the magnet? We understand that magnet attract certain materials wherever some do not get attracted towards magnet. The material which get attracted towards a magnet are magnetic. For example, iron, nickel or cobalt. The material which are not attracted towards a magnet are non-magnetic. What material did you find to be the non-magnetic from table 10.1? Is soil as a magnetic? Is non-magnetic materials? Pujo has a questions for you. A tailor was stitching button thus his shirt. The needle has slipped from the hand on the floor. Can you help the tailor find the needle? Rub a magnet in the sand and soil. Pull out the magnet. Are there some particle of sand or soil stitching to the magnet? Now gently shake the magnet to remove the particles of sand or soil. Are some particles still stitching to it? These might be small pieces of iron filling. Pick it up from the soil. Through such an activity, we can find out wherever the soil or sand from a given place contain the particles that have iron. Try this activity near your homes, school or places you visit on your holidays. Does the magnet with iron filling stitching to the look like any one of those shown in figure 10.6? Make a table of what you find. Magnet with many iron fillings, few iron fillings and no iron fillings stitching to it. Magnet rubbed in sand. How many iron fillings? Name of locations, colonies, towns, cities, village. Did you find iron fillings stitching to the magnet? Many, very few, none. If you fill this the table and send it to the Paheli and Bujo, they can compare the amount of iron fillings found in soil from different part of the country. They can share his information with you. Polar magnet. We observe that iron fillings, if they are the present, stick to the magnet rubbed in the soil. Did you observe anything special about the way the sticks of magnet? Spread some iron fillings on a sheet of the paper. Now place a bar magnet on this sheet. What do you observe? Do the iron fillings sticks all over magnet? Do you observe that more iron fillings get attacked to some parts of the magnet that others fix? Remove the iron fillings stitching to the magnet and repeat the activity. Do you observe any changes in the pattern with which the iron fillings get attacked by different parts of the magnet? You can do this activity using spins iron nails in place of iron filling and also with a magnet of different shape. Draw a diagram to show the way iron filling sticks to the magnet. Is your drawing similar to that shown in figure 10.6? We find that the iron fillings are attract more towards the region close. Pally has these puzzles for you are given to the eccentricals bar which look as they might be made of iron. One of them is a magnet while the other is a simple iron bar. How will you find out which one is a magnet? Two ends of bar magnet poles of the magnet are said to be near this end. Try and bring a few magnets of different shape to the classroom. Check for the locations of the poles on these magnets using from the fillings. Can you now mark the locations poles in the kind of magnet shown in figure 10.4? Finding directions. Magnet were known to the people from ancient time. Many properties of magnet were also known to them. You might have read many interesting stories about the uses of magnet. One such a story is about an emperor in China named Hong Ti. It is said that he had a church with a statues of lady that could rotate in any direction. It had an extended arms. It is a was showing the way. The statue had an interesting properties. It would rest in the such position that it extend arm always pointed towards south by the looking at the extended arm of the statue. The emperor was able to locate a direction when he went the new places on his chariots. Let us make such a directions finder ourselves. Take a bar magnet, put a mark on its end of the identifications. Now tie a thread of the middle of the magnet so that you may suspend it from a wooden stand. Make sure that the magnet and can rotate freely. Let it come to the rest. Mark 2 points on the ground to show the positions of the end of the magnet. When it comes to the rest, draw a line joining the 2 points. This line shows the direction in which the magnet was pointing in its position of rest. Now rotate the magnet by the gently pushing one end in any direction and let it come to the rest again. Mark the position of the two and its position of the rest. Does the magnet now point in a different direction? Rotate the magnet in other. Do you find the magnet always comes to the rest in the same direction? Now can you guess the mystery behind the statue in the emperor's charities? Repeat this activity with an iron bar and plastic or wooden scales instead of magnet. Do not use a light object for this activity and avoid doing it where there are a current of air to the other materials. Also always come to the rest in the some direction. We find that a freely suspended bar magnet always come to the rest in a particular direction, which is the north south directions of use. The direction of the rising sun is the morning. To find out the rough direction towards east where you are doing this experiment, if you stand facing east to your left will be north. Using the sun for the finding direction may not be very exact, but it will help to make out the direction north from the south on your line. Using this you can figure out which end of the magnet is pointing to the north, which pointed to the south. The end of magnet that points towards the north is called its north seeking. In which direction is the main gate of your school situations from your classroom and or the north pole of the magnet? The other hand, the point towards the south is called the south seeking and the south poles of magnet. All magnet have to the poles whatever their shapes may be, usually north and south poles marked at the magnet. This properties of the magnet is very useful for us for centuries. Travelers have been making use of these properties of magnet to find direction. It is said that in olden days travelers used to find direction by the sun Panding's natural magnet with the thread, which they always carried with them. Later on device was developed based on these properties of magnet. It is known as a compass. A compass is usually a box with a glass cover on it. A magnet needle is pointed inside a box which can rotate it freely. The compass also has a dial. A compass with directions marked on it. The compass is kept at the place where we wish to know the direction. Its needle indication the north-south directions when it compass to rest. The compass is then rotated unit. The north and south marked on the dial are the two end of needle. To identify north pole, the magnetic needle, it is usually painted in different color. Make your own magnet. There are several methods of making the magnet. Let us learn the simplest one. Take a rectangle pieces of iron. Place it on the table. Now take a bar of magnet and place one of its pole near one edge of the bar of iron. Without lifting the bar, when you move it along the length of the iron bar till you reach the other end. Now lift the magnet and bring to the pole. The same pole you started with to the same point of the iron bar from which you begin. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30 or 40 times. Bring a pin of some iron filling near the iron bar to the check whether it has become a magnet. If not, continue the process for some. Making your own magnet. More times, remember that the poles of the magnet and the direction of its movement should not change. You can also use an iron nail, a needle or blade and convert them into a magnet. You can now how to make a magnet. Would you like to make your own compass? Magnet and iron needle using a bar magnet. Now insert the magnetized needle through the small piece of cork from let the cork float in water in a bowl or tub. Make sure that the needles does not touch the water. Your compass is now ready to work. Make a note of direction in which the needle point when the cork is floating. Rotate the cork with the needle fixed in different direction. Note the direction in which the needle point when the cork begin to the float again. Without rotating, does the needle always point in the same direction when the cork stop rotating? Attraction and repulsions between magnet. Let us play the another interesting game with a magnet. Take two the small toys a car and label them A and B. Place is a bar magnet on top of each car along its length and fix them with the rubber band. Do opposite poles attract each others? Repulsions between similar poles. In car, keep the south poles of the magnet towards its front. Place the magnet in opposition directions. It car B. Now place the two cars close to one another. Fig 10.13. What do you observe? Do the cars remain at their place? Do the cars run away from each other? Do they move towards each other and coil? Record your observation in table as shown as table 10.3. Now place the toys car close to each other such that the rear side of car A face the front of side of car B. Do they move as before? Note the direction in which the cars move now. Next, place the car A behind car B and note the direction in which they moved in each case. Repeat the activity by the placing car. 10.3. Position of the car. How do the cars move? Move towards away from each other, not move at all. With their rear side of facing each other, record your observation in which case. What do you find from the activity? Do two similar poles attract or repel each others? What about opposition poles? Do they attract or repel each other? The properties of the magnet can also be observed by suspending a magnetic and bringing one by one the poles of the another magnet near it. Bojo has a questions for you. What will happen if the magnet is brought near a compass? A few questions. Magnet lose their properties if they are heated, hammered, or dropped from some height. Also, magnet becomes weak if they are not stored properly to keep them safe. Bar magnet lose their properties on the heating, hammering, and dropping. Store your magnets safely. Magnets should be kept in the pairs with their unlike poles on the same side. They must be separated by the piles of wood, while two piles of soft iron should be placed across their end. For horse shows a magnet, one should keep piles of iron across the poles. Keep magnet away from the cassette and mobiles, televisions, music system, compact discs, and the computers. Keyword: compass, magnet, magnetist, north pole and south poles. Magnet is a natural magnet. Magnet attract materials like iron, nickel, cobalt. These are called magnetic materials. Materials that are not attracted towards magnet are called non-magnet. Each magnet has two magnet poles, north and south. A freely suspended magnet always align in north and south direction. Opposite pole of two magnets attract each other, whereas the similar poles repel one another. Thank you for watching.